Hey guys, so what I want to do today is talk about matter. So we're going to actually start at the bottom with solid. And so a solid is going to have a definite volume and a definite shape. Um, Here, what that means is that it's a solid, right? So it's always going to be the same shape. It's always going to be the same volume. That is not going to change. It's not going to be free flowing like a liquid or a gas or even plasma. And the molecules are staying in place. They can vibrate in place, especially like, if you're thinking of your desk and you bang on your desk, right? You can actually feel the vibrations go through your desk. And so that's what they mean by the molecules will vibrate in place, but they're staying in place. They're not flowing. So for your picture, you have a little square of atoms here, and they're holding their own shape no matter what container they're in. For a liquid, it's going to have a definite volume, but it's not going to have a definite shape. So if I have a glass of water, I can take that glass of water and I can pour it into a bowl. So it's still going to be the same volume, even though it's in a different container, but now it's going to be taking a different shape because it takes the shape of the container. And so these molecules are going to be moving past each other. They're going to be free flowing. So here are some atoms that are taking the shape of the container. For a gas, it's not going to have a definite volume or a definite shape. So it's going to take the shape of the container, whatever it's in, and it can even take up more space or less space. If you've ever had a balloon and you try to squeeze it so it's smaller, that's an example of changing the volume of a gas. And so its particles are going to be moving around a lot more than a liquid will. And so they'll be bouncing around and bouncing off of each other. But notice in this picture here, you have all the little particles are equal in size, which is going to be different from our plasma picture. So plasma, examples of plasma are going to be like lightning and fire. And they also, it also does not have a definite volume or a definite shape. But we're going to have an exchange of electrons, an exchange of particles here. So that's what happens when lightning strikes, right? We've got an exchange of electrons. And so that's what plasma is. And I have a plasma balling class that I showed you guys. And so for this picture, we have these free-flowing particles also, but they're showing you different sizes to show you the difference between protons and neutrons, which you'll talk a little bit more about in 8th grade. So let's talk a little bit about how these can change between each other. So here at the bottom, I have freezing and melting. That's pretty easy, right? When I go from a solid to a liquid, that's going to be melting. If I go from a liquid to a solid, then that's going to be freezing. If I go from a gas to a liquid, that's condensation. So this is going to happen in clouds. It also happens on the outside of your water bottle or your can of Coke. If you have a really cold drink, the water vapor in the air will touch that cold bottle of water and turn into a gas. Then I can go from a liquid to a gas, and that's called evaporation or vaporization. It's turning into vapor. And then over here, this is really interesting. Over here, I've got these two new words that you may not have heard of before. So when a gas turns into a solid, that's called deposition. And when it goes from a gas, so from a solid to a gas, that's called sublimation. So a really good example of that is dry ice. Dry ice does not go through the liquid phase. Whenever they make it, it's called deposition. So they take carbon dioxide and freeze it, and really make it really cold, and they turn it into dry ice, and then it actually sublimes or goes straight to a gas instead of actually melting and turning into a liquid. So hopefully we'll get some of that and play with that for Halloween. Okay. Thanks for watching.
Thank you for visiting Somo's YouTube channel. Look for us on Facebook, Instagram, and Snapchat. And don't forget to like and subscribe.